Hi, I'm Dr. Raj Shah of Math Plus Academy, and this math treat is called Cookie Monster. What we want to imagine here is Cookie Monster would like to eat all the cookies in these jars as quickly as possible. But Cookie Monster has to follow a simple rule. He has to eat the cookies in steps. In each step, he can choose any number of jars that he wants, any set of jars. Maybe it's A and B, or A and C, or A, B, and C, whatever. Once the jars are chosen, Cookie Monster has to eat the same number of cookies from each of the jars that he's selected. That would be one step. And then, of course, Cookie Monster wants to eat these as quickly as possible, so he'd like to empty the jars in as few steps as possible. That's going to be our job, figuring out the optimal way to eat these cookies under this rule. Let me give you an example. Imagine 3 jars, 1 cookie, 2 cookies, 3 cookies. You'd like to eat them following this rule. One thing you could do is say, well, in my first step, I'll just choose jar C, and I'll eat all 3 cookies from that jar. That is a valid step. Another option for your first move could be choose all 3 jars, A, B, and C, and eat 1 cookie from each of them. 1 from here, 1 from there, 1 from there. Then you'd have emptied A, you'd have 1 left here and 2 left there. That is a valid step. Then your next step, you would try and empty out the last couple cookies from each of those jars. Now, you can maybe see a really simple strategy would be, first step, choose jar A and eat all those cookies. Second step, choose jar B and eat all those cookies. Third step, choose jar C and eat all those cookies. And in 3 steps, Cookie Monster has eaten all the cookies. Yay! Your first challenge is, can you do this in less than 3 moves? Can you do it in 2 steps? Is there a way for Cookie Monster to eat all of these cookies in 2 steps? What's another challenge? Well, if you figure that out, then just add another jar, maybe jar D with 4 cookies, and just kind of build up. Can you find a pattern, a system, an algorithm that minimizes the number of steps the Cookie Monster would need to eat all those cookies? Your third challenge is start changing the numbers a lot, so they don't have to go in order 1, 2, 3, 4, 5. The number of cookies could be any number you want. So maybe I add a jar, and now I don't want to always draw all the cookies, so maybe I'll use some numbers here. So let me erase the cookies and put in some numbers. Maybe we have 1, 3, 5, and 6. How many steps, what is the fewest number of steps it would take to empty out these 4 jars? Again, I will play out one possible way. Let's see. Maybe I want to eat 5 cookies from these 2 jars. I can get rid of a lot of cookies that way. Then I'll be left with 1, 3, this one will be empty, and 1 over there. What would I do next? Maybe my next move is to eat all 3 of these cookies. Okay, then I have this. And then I think you could see a really good move next. Eat 1 cookie from both of those 2 jars, and you're emptied it out in 3 steps. 1, 2, and then a third step to make all zeros. Can you do this in less than 3 steps? So for these different jar sets like this, what is the optimal way to do it? Again, can you come up with a system or a process that would help you get to these minimum answers as quickly as possible? So that's the Cookie Monster problem. There are so many different variations that you could try here. You could go simple. 2 jars. Get rid of all the other jars. Pick some numbers to put in there. What's the minimum number of moves it would take for Cookie Monster to empty those? Could it be done in 1 move? Could it be done in 2 moves? Would it ever need 3 moves? So that's a simple example. You can build your way up. You could try really crazy patterns, like what if these were square numbers? 1, 4, 9, 16. How do you empty that as quickly as possible? Or Fibonacci numbers. 1, 2, 3, 5, 8, 13. how would you empty those as quickly as possible? So a lot of math to explore here. And as always, I just want you to have fun playing with the mathematics.